Welcome back, welcome back. The final quiz question of the day was, what was the name of the asset that Jed issued and sold on Stellar? The answer, hug. Now, you can actually redeem it with Jed for a real world hug. I'll have to do some digging to find out if anyone ever did. I'm not sure. So we've had a great day so far learning about some of the engineering solutions that empower developers to build better on Stellar. We've gone deep into the Stellar transaction compiler, the automated trading bot for the Stellar DEX, aka Kelp, and a new method for account recovery. And our final session of the day really yanks that thread. Smart contracts are a hot topic in the world of blockchain, and our next presenter, Tyler van der Hoeven, ecosystem evangelist at SDF, is going to give us a progress and process report on a proposal for making them possible using Stellar. Now, it's a bleeding edge that's really pushing the envelope, and it's generated a ton of interest and enthusiasm in the Stellar ecosystem. So it's the perfect way to end our day. Tyler, take it away.
Thanks, Justin. It's fantastic to be here. I am Tyler van der Hoeven, the ecosystem evangelist at the Stellar Development Foundation. It's actually been a year since I joined the SDF. One of my first tasks when I first came on board was to give a talk at the very first Meridian conference. So it's quite surreal to be back again, now virtually presenting on something that I've been spending a lot of time on over the past year, improving and pushing forward. It's actually, so back in July, I did an engineering talk that we posted on our YouTube channel around kind of introducing the idea of what we're building. And so today we're really looking at where it's come since then, how you can get involved, and ways that it's changed and improved. I will touch a bit on exactly what it is and why it's important. But if this is all brand new and a bit confusing, you'll want to pair this talk with the one that I gave in July. All right, so progress and process report for the proposal for Turing-complete smart contracts for Stellar. This is actually going to be one of the only times that I say the word smart contract in this talk, and this is primarily because the idea of smart contracts is a bit loaded, and I'd rather not have to swim too much through the definitions or terminology that's around smart contracts, and instead focus more on what exactly we've built and why it's important for the Stellar blockchain. So where we were in July, so when I spent a lot of time as an ecosystem evangelist talking to the community and engaging with applications that they're building or problems that they're having. And so back in early 2020, this idea of decentralized transaction creation, I had an assumption that it was important. We see this idea of DeFi and the ability to kind of create a company or a service in a decentralized way. Presenting that to the Stellar ecosystem seemed like something that was important. There was kind of an assumption that that would be received well. So I started working on a proposal for that, and then presented that in July. And as Justin mentioned, has received a lot of attention and interest. And since that initial proposal and proof of concept, we've kind of grown a bit. The idea with what we're building here with Stellar smart contracts or Turing-complete transaction creation is that it's going to eventually be a SEP. It's going to be a Stellar ecosystem proposal. It's in a pre-SEP stage, though. That doesn't mean that all the work is private. However, we are doing a lot of our work in public, which I'll talk about a bit in a moment, around a working group that's spending a lot of time thinking through how to best implement this. And the implementation has grown a lot since July. So that's really what we're going to be talking about. Maybe you've seen this slide, bit of a mess, but don't worry, it's gotten even messier. So we're going to kind of go through, not this one, but how this particular diagram has changed over the past few months with Turing Signing Servers. So where are we since July? So from where we were, we now have a working group. We have a group of folks that have kind of gathered around the idea of decentralized transaction creation. And you can find that team. It's an open team right now on Keybase at keybase.io/team/stellar_TSS. And we also have a homepage. And this is probably, if you're going to really grab onto anything from this talk, it's going to be our tss.stellar.buzz homepage. This is where we're keeping track. It was getting a bit hairy and wiry keeping track of all the documents and conversations that were going on. So be sure and head over to tss.stellar.buzz to keep track and monitor the progress of this proposal. And I think it's worth talking a little bit about, so I'm going to go ahead and switch slides here to this mess. Before we dig into it too closely, I think it's worth backing up just a little bit and giving an overview of what we're trying to accomplish with Stellar smart contracts, or what I'm calling Turing signing servers. Very similarly to what Lee just presented with the account recovery servers, we need a method by which we can create transactions. So we can do something in a decentralized way, in a programmatic way, without having to have humans involved on both ends. Within Stellar, you've got decentralized transaction execution. And if we were to take a model that's a little bit closer to what we're getting with Turing signing servers, we would have Ethereum, where you have both transaction creation and transaction execution happening within the same request. So both, you basically just send a request into the EVM, into the Ethereum virtual machine, and it says, hey, I want to perform some action, and that is a Turing-complete program that then performs some sort of action and actually changes or mutates the state of the ledger. So those two things are happening inside of the virtual machine. That's very different than the way that Stellar works, where really you just have transaction execution. You don't have Turing-complete logic. You're not able to do whatever you want within the Stellar ledger. You have to follow a very strict set of parameters and guidelines within the structure of the XDR and Stellar core. This is fantastic because it allows you to move very, very quickly. And also to ensure some level of assurance, like here's exactly what's going to happen. It allows you to have transactions that aren't immediately executed, where you can kind of store those things and then move them maybe at a later date. And it also just, again, allows the speed and the cost to be very low and assured at some level. The problem is, or really the thing that we need, though, and I think DeFi has really begun to prove this, is we need a mechanism by which we also have transaction creation. Because if all I have is decentralized transaction execution, which is incredibly important, we're still missing something around decentralized transaction creation. How do I get a transaction made? And this is where I'm going to take this diagram and begin to break it down so that we understand kind of really what we're trying to achieve and how we get there. At the end of the day, all we're trying to do is give a user access to a Stellar account. So I'm going to use an example of recurring revenue. So if you have a subscription model to something and you wanted to withdraw money at a set interval underneath a certain set of parameters, whether it be amount or an interval every month, or only under certain conditions if they haven't upgraded or changed the parameters of their subscription. How do I accomplish that within Stellar? Because all we have again within Stellar is transaction execution. So somehow we have to create this parameter of a payment outside of the bounds that Stellar might permit us to have. If I might have some really complicated logic for how I want the transaction created. But if I don't have that programmed, I'm going to have to rely on some central third party to do that for me. And so you have the transactions within Stellar, which are composable. You can create them underneath a lot of different parameters. Like maybe I create a transaction that says, every month I would like your account to pay me $100. But how am I going to accomplish this? As a user, I don't want to give you access to my account directly, because then you can do a lot of things that aren't just taking $100 from my account every month. You could merge my account away, or take all of my money, or add yourself as a signer, do all kinds of things that I may not want you to do. So what the user, or what the service is then going to have to do, is actually to compose a transaction on their end, and then every month send that to me. And then I'll choose to sign it or not. But this is very different than the flow that we get, where I can just tell my bank account or my Netflix account to just withdraw from my account every month, and we're fine and dandy until I decide to cancel it. I don't have to sign that transaction every month. And so you might do something like pre-signing transactions. So at the outset, when you first subscribe to this new Netflix, they send you a bunch of transactions, says, hey, here's all of the transactions for the next 20 years. Go ahead and pre-sign these, and we'll submit them every month, we hope. And we won't submit them all at once. So maybe you could do some time bounds or something that would allow a little more flexibility to ensure that they don't submit all of those transactions all at once. But then you get into issues with sequence numbers. And then it's also if you need to change something like the amount or intervals, maybe you want to upgrade from a monthly plan to an annual plan, all of those transactions need to be invalidated and new transactions created, and it can get a bit messy. And so this idea of connecting Netflix or connecting a service account to my controlled account or giving them some sort of access to my account, but only underneath a very specific set of parameters, that's one very, very strong use case for Turing Signing Servers. And it was the original one that I tried to solve for. There are other use cases. Another one is insulation from certain regulations where I'm a custodian, right? If Netflix has access to my account, they're a custodian of my account. And so they have to ensure certain assurances around how they're storing my money and how they're making use of it. And I have to agree to their terms and conditions. This isn't decentralized at all. And I think there are improvements to be made here for service providers who want to create really powerful experiences, but don't necessarily need or want to store all the money. They don't want control over your account. They just want to be able to access it under a very specific set of parameters, a la the smart contract. And so understand that while the process by which we accomplish this is complicated, the goal is actually very simple. I just want to be able to give controlled access to an account to some third party. So in this case, the controlled account is the user, that would be Netflix, and the controlled account would actually be me. The way we accomplish this is through a TX function creator. So we have to upload a smart contract. There has to be this, in my case, it would be a JavaScript contract. It could be any programming language, but that is uploaded to several different Turing signing servers through a TX function. So it's kind of like a serverless function. All it is a method, a function that is uploaded as a code snippet to these Turing signing servers. They would then spit out a hash. And what they send back, so when you create this contract, you upload the exact same contract, the exact same file to every Turing signing server. There'll be multiples of these. This is where you're going to get some of that security. So in this case, in this part of the diagram, there are 3 of these Turing signing servers. You upload that same contract to all 3 of those, and then they each send back a signing key. And so this is going to start to sound a little bit familiar to what Lee was presenting with the multi-sig solution that we're coming up with for achieving this controlled access to an account. Each one of those Turing signing servers will send back a key, and then those keys will be added to, they will come back from the request that was made when you uploaded the contract. The response will be a key, and then those will be added to the controlled account in a multi-sig scenario. So let's say, in this case, I want all 3 Turing signing servers to be signers. I might set the threshold to a payment to 3, and then the weights of the keys that I'm adding from these Turing signing servers that I just uploaded the contract to, I'm going to add those with weights of 1 each. And so no single Turing signing server is a custodian of the controlled account, but together they all can sign for, in this case, a medium threshold transaction on the controlled account. But how do you actually get them to sign for a transaction? Well, it's through that contract that you just uploaded. That contract becomes an endpoint that you can then hit via a REST API. You say, hey, I would like to look up this contract underneath any parameters that you might have uploaded, like amount or a source account, or you can upload along with your contract a number of different parameters that might be necessary to actually perform the logic of the smart contract. So those, you hit that endpoint with the parameters, and then an XDR is produced. That's why they're called TX functions or transaction functions. They're not necessarily smart contracts as much as they're just a function that produces an XDR. And because it's the same code, the same contract on every single Turing signing server, it must produce the same XDR on all 3 of those. And then each one of those will sign, each one of those contracts, each one of the Turing signing servers with the key that they sent back. They will sign that transaction with the secret key that they've stored, along with the public key that you've added to your controlled account. They will sign that XDR, 1, 2, 3. Each of those comes back. You combine those signatures together on the XDR that was the same across those 3 Turing signing servers. And now you have a valid signature for that XDR. Quite simple to say, but incredibly, incredibly powerful. Simply because now I've given access to my account to anyone who follows the parameters of the contract. So whatever the contract permits is now possible through those Turing signing servers. So in the case of the recurring payment example, now somebody can make a request, but rather than making it directly to my account, they make it through the Turing signing servers to the contract that I've uploaded or that someone has uploaded and that I've added those keys to my controlled account. That request comes in, it says, okay, we look at the controlled account that's coming in. The source account maybe is one of the parameters on the incoming request. They look at that account, the contract looks at that account, says, okay, it's been more than a month since the last payment, so we're going to go ahead and generate an XDR. Each of the Turing signing servers adds 1/3 of the signature. That comes back, it's a valid signature, or it's a valid XDR with a valid signature. The transaction is submitted, the payment is made. Aha, but oh, sneaky, sneaky Netflix tries to make the same request. The request comes into the contract looks at the controlled account. Uh-oh, it hasn't been a month yet. The request is denied. The transaction is not created and signatures are not added to the XDR and the payment cannot be made. And so you're adding this middle, almost like a firewall in between those who want to access your account and the actual account. And that firewall is programmable, which is something we haven't seen, but is native to protocols like Ethereum. And it is incredibly powerful and important that Stellar has an option for something like that. And Turing signing servers allows for it. And so this is the flow. You make that request in where you have an outgoing request to your different Turing signing servers. They're making that request to the contract. And what comes back is that partially signed XDR going back to whoever is calling the contract, combines those together into a fully valid signed XDR. That gets submitted to the Stellar network on that controlled account. And assuming that the signatures were valid and the XDR was valid, the transaction goes through. The last piece to this, and this is super important, is why on earth would someone run a Turing signing server? Well, the first obvious answer is you need it for your own services, but the reason that this is powerful is that it's not a single entity that's running Turing signing servers, not just you running Turing signing servers, or what have you actually gained. The way that this is accomplishing decentralization is that there's lots of different people, lots of different entities that are running Turing signing servers, and you get trust through not having to trust anyone with everything. And you also get that insulation where no Turing signing server has entire complete control over any single account. And so each of these individual Turing signing servers needs to run a very good Turing signing server and respond to requests. But why in the world would they do that if they're not directly involved in the benefits coming from the computation that they're running on transactions? Well, that's where fees come in. And so fees are charged. Fees are central to the Turing signing server flow because rather than there being a very limited set of Stellar operations, it's Turing complete. Who knows what these transaction functions are running? And so there has to be some mechanism to recoup the Turing signing server processing powers for them to recoup on those costs and charge those to, in this case, the TX sponsor. This is something that still is quite new. There was a system that I built in place initially where the actual contracts had to include payback logic, but it got a little bit complicated and it was very restrictive to the ways that people might choose to use Turing signing servers. Again, this is why it's so important to have working groups, people that are actually interested in using the products that you're building, and why our ecosystem is so impressive is there are people that are actually using these and building on these and finding issues with it. And I have a very limited set of resources at my disposal as far as brain power and use case ideas to be able to know if I'm building the right thing or if we've built the right thing. So having a large working group is super powerful for this. And one of the complaints or one of the requests was we need more flexibility in how and who to pay or who's going to pay these fees to Turing signing servers. So we're trying to come up with a really good solution for this. We've got a couple of really good ideas. Some of them are in flux at the moment, which is, again, if this is something that's super interesting to you and if getting paid for running services is something that you are interested in, this could be something you want to jump into to see how we're accomplishing this. Right now, the way that it's accomplished is through a TX sponsor, a transaction sponsor. So if any user wants to actually call a TX function, first they have to get sponsored. That sponsorship could be yourself, like if you want to call your own contractor, if you are your own sponsor, that's totally possible. There's no one central authority for these things. So you could set up your own sponsor account. In general, that won't be the case. You'll be providing a service to your users, and the service will be the TX sponsor, and they will allow usage of their sponsor account to their users through a very strict JWT flow, similar to like SEP10. And then that JWT would go into the TX functions and say, hey, this is the request. We have permission to use a sponsor account. And then those Turing signing servers would be signers. They would be additional signers on the transaction sponsor account, and periodically would draw money from the TX sponsor. One of the reasons that this is so important that we have this flow rather than just making payments on every single request is that if you have a very popular contract, you can't be making payments on every single request to the actual blockchain, particularly because these could be very, very small. It's even possible, maybe even likely, that fees for running a Turing or running a TX function would be comparable to the actual network fees. So why you'd be paying a fee to pay a fee that's smaller than the actual fee that you're paying in Stellar. And so there has to be a way to kind of have this side net of combining fees together until it reaches a certain threshold, and then you settle on the network. So it could be a really interesting use case for these like fee channels that have been bouncing around. Maybe a problem without a use case. We might have a use case now for how that could be very useful. So we're looking at that. We're still exploring the best way to accomplish that. Even since this diagram was put together, we've come up with a little bit of a better flow that doesn't involve JWTs, but actually uses signed transactions that are unsubmittable, but at least are signed to prove ownership over an incoming request, to reduce spam and also make sure that Turing signing servers are getting paid for the services that they're providing. And so that's, in a nutshell, Turing signing servers. Obviously a bit of a messy diagram, but a very, very powerful and useful feature that we're building as a SEP into Stellar. Again, I would strongly encourage anyone who's interested, even at a kind of tertiary top-down level, to get involved in the tss.stellar.buzz, to look over the articles and videos that have already been recorded. We've got some really interesting demos to peruse, along with their TX function code that you can actually look through the code that's being run within the Turing signing servers. And then getting involved in the Keybase working group. There are several individuals and enterprises that are working on actually implementing Turing signing servers to see if it's the right solution for this kind of problem. So I would strongly encourage getting involved where you can. And I would love to answer any questions that may have come in through that.
Great. Thank you so much, Tyler. I'm just trying to start my video here. Fantastic. We're getting some questions in, and I think that there's sort of a group of them that are about getting involved. So you sort of just went over this. The best way to get involved is to
go to tss.stellar.buzz and then figure out kind of where you fit in best. The thing that we need the most for this to really reach main level adoption is use cases. So if you've got an idea for like, ooh, I wonder if it's one of those interesting things, like, could Turing signing servers do XYZ? Like, the answer is going to be yes. It doesn't necessarily mean that it should be yes. There are lots of good use cases and bad use cases, but we really need people implementing this and trying to use it and saying, okay, I really would like to be a non-custodian. I would like to explore building a service that utilizes the idea, the concept, the ability of controlled access to an account without having to actually be a custodian of that. I mean, this is incredibly common. This is the whole point of DeFi. So there's tons and tons of use cases, but we need people that are actually getting involved building those things and then helping to build the protocol out to where we have a lot of strong use cases that are driving forward the protocol to be the right thing so that we can get this to a SEP that's both drafted and eventually active.
Great. And we have a question from Jeremy, and I think it gets at part of the way that this works and part of the way that it doesn't work. Jeremy asks, Jed had mentioned that for security reasons, something like this wouldn't be part of the base protocol, the Stellar protocol. And And then he says, is that still the case? And how would that work? So
Yeah, go ahead.
no, you go
Absolutely.
ahead.
Yeah, it shouldn't. It really can't be part of the core. At least they can't run together. They might be able to run in parallel. And in many ways, this is a parallel running protocol where you've got Turing signing servers, which are running complicated, but Turing complete logic. And the whole point is Turing complete logic. To actually run arbitrary code, you don't know what you're running. And so things might be slow, things might be complicated, things might get messy, and they might get expensive. And we see this all the time with the Ethereum fees just constantly all over the place. And it's hard to build a viable production ready product when you don't know what your fees are going to be. You don't know if the system's even going to be up. And that can be debilitating if you really want to take your product mainstream, if you're worried about succeeding. And so being able to separate the transaction execution to make sure that that's always quick and always stable, separating that logic out from the actual transaction creation. And that's really important. It's still really important to be able to have decentralized transaction creation. Ethereum has proven that. There's no questions that that's important, but they do need to be separate so that we're still fast and cheap, but we also have the customability, the programmability that's necessary. But creating the XDR should be different from executing the XDR. Those should be different things.
Right. So this is two different systems, right? There's a parallel system where you can create these XDRs and then you can submit them to settle on the Stellar network.
Exactly.
Correct? Great. I'm getting a lot of questions about timeline. When do you think it will be ready to use in action, for instance?
As soon as you get in there and start implementing it and help out. I'm going to give a little, didn't even go to college for compute. I didn't even go to college. So the limits of my ability to push this protocol forward are becoming apparent. So I need smart people to jump in, start implementing this, building it, showing where the problems are, and kind of taking over to get this over the finish line. I think through notepads and programming, like I never build something without having a reference implementation. But the problem is then everybody focuses on like the house, when what I'm trying to build are hammers and drills, the protocol of the thing. So I need people who understand that, who help me build better hammers and drills.
Right, or maybe a blueprint, right? Like a blueprint.
Right, exactly. Yeah, the template of the thing. We need better tools and protocols. And right now what we have is a pretty solid reference implementation, but we need people that are focused on the tooling and can help push the protocol forward.
I would say one caveat, you do not need a college degree or specialized courses. This is something that is being invented right in front of us by people, who are sort of ingenious and innovative, and innovators. That ability comes from sort of your own curiosity, right?
Especially when it comes to implementing it and using, like we have, if you go to that tss.stellar.buzz, we have an API that you can use right now on testnet. With API, you can upload contracts and start calling them right now. Like we've got an implementation that can absolutely be used and works really well. It's just, it needs to be used so that we know where have we missed something? Where do we still need to shore up features so that we can push it into a SEP that's really quite solid.
And what are you hoping to discover as people use it? What kinds of things are you looking to investigate?
Well, I would say the thing that I really want to see the most is this. So we have open source code, but I really want to see open source opportunity where you don't have a lot of siloed functionality held within individual enterprises. This is something that's actually quite new to the just cryptocurrency space. And I think DeFi is pushing this forward a little bit, maybe not always in the best way, but in a really interesting way of what happens when you're not just open sourcing the code of what you're doing, but actually open sourcing the ability, like templating how to run a financial service in a decentralized way, really sort of turning the tables on, you can provide a service, but not actually have to be responsible for keeping that service up and running. You can put code out there that anyone can run, and it can run that service. Somebody else can run the same service in a different way, or they can run that service underneath their own parameters. So rather than it being individual siloed services that have these features and functionalities, anyone can run those through the templates built by Turing Signing Servers, where it's just some code, and anybody can get access and actually start running that and provide lending services and these recurring revenue services that, all these different financial services, but in a decentralized way where there's not one entity that everybody's like asking, can you please sign this transaction for me?
Cool. Well, thank you so much, Tyler. I mean, it's definitely amazing to see innovation unfolding before our eyes, and also great to see it's being propelled by ecosystem-wide cooperation and collaboration. If that presentation piqued your interest, I urge you to get involved, join the Turing Signing Server conversation. I mean, this is definitely how open source should work, as Tyler just said.